Hi, I'm Grygorii, and I'm here. Hope you're already awake after all the exercises that we had in a previous talk. So let me introduce myself properly. My name is Grygorii Luchytsky, and I'm managing Firebase Engineering Productivity Group at Google. I'm really excited to be here and share with you how we test Android SDKs at Google. And more specifically, I'm going to talk about how we test Firebase Android SDKs, because that's what my group is responsible for. I mentioned that I'm managing Engineering Productivity Group. What is this group? What does this group do, right? Engineering productivity. So our main goal is to make our developers productive. And what we do, we build tools and different infrastructure pieces, frameworks that makes them more productive. And testing is one of the aspects that developers need some help and guidance. What is Firebase? How many of you know what Firebase is? Please raise your hand. Awesome. I see a few folks already know what Firebase is. How many of you used Firebase in your apps before? Awesome. Great. So for those of you who doesn't know what Firebase is, I'll tell you. Firebase is Google's mobile app development platform that helps developers to build great apps and grow their businesses. It provides a cohesive set of tools and APIs and services backed by Google offering from cloud, analytics, and ads. As you can see on this slide, we have, I think, like 17 or 18 different products. Some of them, on the left column, you can see allow mobile developers to build their awesome apps, like products like Firestore, Functions, and recently we added a beta version of MLKit, allow mobile developers to build great experiences. Mid-column, you can see that we also care about app quality. And we provide tools for developers to improve their app quality. With products like Crashalytics, you can make sure that your app doesn't crash. Or if it crashes, then you can improve and fix your crashes in different devices, form factors, or API levels. Performance monitoring, so you would get some insights in your app performance, and Test Lab to allow you to test your great app beforehand. And I'll talk a little bit about Test Lab later on. Also, there are a lot of tools that will help you grow your business. With products like analytics, predictions, A/B testing, cloud messaging, you would be able to reach your audience and really get to know it. That's basically like a very similar slide, but it would give you an overview that a lot of our SDKs actually available at many different platforms. At least we support iOS, Android, and web. A lot of our products also are targeted for cross-app development with C++ version of our libraries, and as well as game development community with Unity SDKs. So let me talk about what is a testing philosophy at Google. I'm assuming many of you already have heard this picture or some version of this picture. It's called test pyramid. And the idea behind it is very simple. On the bottom layer, you want to have unit tests. And those unit tests should cover majority of your functionality. Unit tests usually very fast and small at their size. So they're easy to maintain and debug. Second layer is integration tests, where you would make sure that you test integration of different units of code. And the last, on the top, you have UI test, where they would exercise your applications or SDKs from UI level. And as you can see, it's a pyramid, right? So the higher you go in your vertically, right, in your pyramid, the less number of tests should be. At least like that's the idea behind test pyramid. And also, the higher you go, you would increase test execution time, maintenance of your test, and the time you need to spend on debugging test failures. But from the other hand, the higher you go on a pyramid, you would increase test fidelity. So like your tests would actually test what your users would see. So there should be a balance. On this slide, you can see all those testing types and different characteristics. So unit tests, they're small, fast. We, at Google, we prefer Robolectric test framework, which runs on JVM. Another option is instrumentation tests that would be able to run on emulators or devices. Those tests would be a bit slower because you have you need to spend some time to bring up emulator if you're using emulator. And the key point for unit tests is that all your external dependencies should be mocked out. Network, database, disk, all those should be mocked out. So you definitely should not have, I should not use real ones in your unit tests. Integration tests, we call them medium tests. They usually much slower than unit tests. They usually use instrumentation, run on devices or emulators. And again, things that you don't test, mock it out. And UI tests. Sometimes we refer to them as end-to-end tests. They are large, very slow. We use two different frameworks. Both of them, I think, were built inside Google. Espresso, very good for UI testing if you test your app only in one process, and UI Automator if you want to go outside of one process boundaries. Again, those tests could be run in emulator and device, or device, and usually your dependencies are real. Again, unit tests, and specifically in Firebase. Who is responsible for unit tests? So in Google in general, and Firebase specifically, developers. The answer is very clear. Developers are responsible for testing all the units of code that they're creating. Again, I mentioned that in Firebase, we prefer Robolectric. And the main reason, because of speed of execution. One key point that you always want to measure test coverage. Because if you don't measure things, you can't improve them. And if you don't know what your test coverage is, you don't know what the level of confidence you can get out of your unit tests. In Firebase, and I think it's applicable to Google in general, we target to have at least 80% line coverage from unit tests. And we run our unit tests, and because of they're fast, it's not very expensive to do. We run them in pre-submit, so before any commit is being committed, so before commit, and then as part of continuous integration as well. Integration tests. They focus on integration between different units of code. Again, developers are responsible for writing integration tests. Our team is responsible for providing test infrastructure for them to make it much more easy to do. Usually, integration tests also use instrumentation and run on Android emulator, because it's much easier to get coverage of different API levels with emulators. Again, we try, and that's my team's responsibility to build hermetic test environment in order to make sure that tests are less flaky, more repeatable, and hermetic meaning that each task starting with exactly the same, in the same state, order, and basically clean up after itself. And ideally, it should not involve network, right? So like if you want to use real environment, then it should be a local environment. If you want to use a fake environment, then it should be, again, local fake environment where you would start from exactly the same state every task. And they usually, all the tasks could run in parallel, meaning that two developers could be trying to submit a change at the same time. So the same instance of a task could be running at least twice or 3 times. And those tasks should not have cross dependencies. So that's why hermetic environments are key here. And again, because integration tests are still medium-sized tests, we are able to run them in pre-submit as well as in post-submit as part of continuous integration. Here's a question for you. How would you test an SDK? Anyone? I give you an answer. Yes? Awesome. That's a good answer. That's actually what we do as well. So we use UI tests to drive test apps, sample apps, as acceptance tests before we release, as well as a way to test for compatibility. Let me quickly talk about UI tests, right? So like UI tests are joint responsibility of our team, engineering productivity group, and developers. Meaning that even if some of UI tests would be written by us, developers are still responsible for maintaining them and making sure that they actually look at any test failures signals from those. Usually we use 2 test frameworks, as I mentioned, Espresso and UI Automator. Ideally, those UI tests should also run against a hermetic environment. That's where my team is helping up to set it up, but can also run against prod and or pre-prod environment. And for SDKs, it's very critical, right? Because once you release your SDK, developers could build an app using that SDK. And that app would be on millions of devices of different users. And our job to make sure that that app is going to work always, even though we push in new binaries of our backends. It should always work, right? So we want to make sure that we test compatibility between our SDKs of even like older versions with unreleased backends as well. So that's why we test against pre-prod version or head version of our backends. Usually UI tests run in post-submit because, as we already know, they're kind of slow. And we use them as acceptance tests for release candidates, meaning that like that's a final step to make sure that what we going to ship to our customers, all of you developers, is actually working the way it's supposed to work. And you would be using it for app development, right? So like we should be using it as part of apps. Compatibility testing. There are several aspects of compatibility that we consider for Firebase Android SDKs, and not just Android. So one of them is very obvious one, SDK API compatibility, right? You, as I just mentioned, once you release your SDK, it's in the wild, right? And all the previous versions of your SDK supposed to work with always, right? Or like whenever it makes sense, they still should work. So that's one aspect. The other one is compatibility between different Firebase SDKs. are they compatible with each other, right? So like, let's say Firebase database, is it compatible with auth? And so forth, right? So like, is there any conflicts? And to be honest, there have been situations when there are conflicts. And that's our job to find them early enough to make sure that we release good products. Another aspect of compatibility is Android API versions compatibility, right? So like your apps ideally should work with different API versions, so like you would reach as many users as possible. So we do test our SDKs with, I think, starting from API 15 or 14. Compatibility with different versions of Google Play services. So Firebase SDKs are part of Google Play services. So we actually test the other way around, because Google Play services are being pushed to user devices automatically. And what we want to make sure that the latest Google Play services actually compatible with all the previous versions of SDKs. Because like, if you have an app that uses all the version of Firebase SDK, it still should be working fine and as expected with the newer version of Google Play services. And I think I already mentioned this aspect of compatibility is compatibility with unreleased or latest pre-prod version of our backends. What other testing types do we care about? So I think I mentioned that when I was talking about coverage, but that's actually applicable not just to coverage. One of the key aspects of testing philosophy at Google is that you need to measure. You can't improve things that you haven't measured. So this type of testing is critical for SDKs, right? Because you want to make sure that app developers will not be penalized by size of their app if they use your product. So for binary size, there are two questions that we ask ourselves. How much bigger will my app get when I add Firebase Android SDK? Or several of them, right? And how size impact changing from release to release? In order to measure that, we measure Firebase size impact as a delta between app that is not using Firebase SDK and apps that exactly the same apps that use Firebase SDK. And that's a principle that we use for many types of testing that I'm going to talk about later on. And we measure size in 3 different configurations: without proguarding, with default proguarding, and with aggressive proguarding, just to get a sense what the size impact we would get. Another aspect for SDK, and I think this aspect is also critical for all the Android app developers as well, is startup latency. And for SDK, we search for startup latency impact on the apps. And again, another aspect is like regression of startup latency. And for Firebase, it's not as easy to measure startup latency, because you cannot just measure or like start a timer in your application on create method or like main activity on create method and finish it when your application, when your activity is being displayed. Because a lot of initialization is actually done in content provider, which is being initialized before onCreate method is being called. So what we do, we use internal in-house developed testing frameworks in order to measure the delta between when the process has started and when a main activity on pre-draw event get called. Memory, another aspect, right? So like a lot of emerging market devices actually don't have a lot of memory. They might have as low as like 512 megs of RAM. So you want to make sure, in order to enable developers to target those markets, your SDKs should not use a lot of memory. Another aspect of memory testing is like, does your SDK actually leak memory? And in order to verify that, we use, again, in-house developed framework, but what it actually does is use dump sys meminfo and get some statistics, and our job is to create a test that replicate intended workflow for SDK and see if we leak memory over time, what is our delta on memory comparing to apps that don't use our SDKs. Battery, very important aspect, right? Because like, I think everyone carry a phone in their pocket, and one of the worries at the end of the day, will my battery die or not? So in order to make sure that we are good citizens in Android community, we also do battery testing of our SDKs. And the key part that we actually have a lab with Monsoon devices. Monsoon devices would help you to measure current going through the battery. So I didn't do this myself. That's one of the advantages of being at Google. So like you have a lot of experts who would be able to set up a lab. What they actually do, they remove a battery of your device, connect directly to Monsoon device that would measure current. And all of our testing is actually done when the app is in background. Because if your app is in foreground, then screen will be basically the majority of your battery consumption. And everything else would be noise. So what you want to make sure with the battery testing, that your app is not draining battery when the user doesn't use it, which unfortunately sometimes happens. That's why at the end of the day, your battery is almost dead. So I think I briefly mentioned this. Should you use device or emulator? How would you choose where to test? And there is no one answer that would fit all the cases. But here's principles that we use in Firebase. So if you have device-specific application or SDKs that actually depend on hardware pieces of device, that could be like camera, it heavily uses GPU, or like, let's say, notifications, then you probably want to run those tests on devices. For simple correctness tests and like maybe stability tests, like tests for crashes, you probably don't care. You can test them on devices if you have a lot of devices in your lab, or emulator. And for performance testing, don't run them on emulator. Always test them on device. Firebase Test Lab. I think I mentioned that that's part of Firebase. And what it is, it's basically cloud-based infrastructure to help developers around the world to test on real devices. And actually, they support virtual devices as well. Recently, they announced in Google I/O that they started to support iOS devices. I think it's beta, but so Test Lab supports both Android and iOS devices. You can execute your tests directly from Android Studio, from command line, and you can integrate it into your CI system as well. It supports both Espresso and UI Automator for UI testing. And there is also a cool test called RoboTest. What it does, it's basically like crawls your app and trying to crash it. So it verifies for stability, and it's very easy to set up, and you should try it. Firebase have a free tier, so feel free to try it, and if you like it, you can continue to use it in your app development lifecycle. Thank you. Any questions? Yes? Can you please pick up maybe Mike?
Can you talk about the specifics of how you test things like the latency differences, the battery life differences? Are you saying that Firebase maybe would provide some of these results for us, or?
So latency, I don't think that Firebase Test Lab will provide those results for you. So what I was mentioning, like how we test it internally to make sure that our SDKs don't increase your app latency or startup latency. So specifics for startup latency, was that your question? All of them. So the way we approach that, very simple. So we built 2 apps. One is like very simple app. It could be like default app that doesn't use Firebase. And the other one is the one that is using Firebase. And you set up your infrastructure that you run those tests. And your test could be like very simple one. Let's say if you test for startup latency, right? So like all your tests need to do is to start your app and measure and report latency. So like we have, you start the timer. Actually, like for startup latency, you don't start a timer because there is API call that would give you exact timestamp of when your process has started. And then you take a timestamp when main activity on pre-draw event. Take delta in your app under test, delta from your app, your reference app. That would be your impact on setup latency. Same with battery, right? So like with battery, the key aspect there that we don't see any surprises in the sense that like, for example, if your SDK doesn't do anything in the background, you don't expect to see a current. So you basically measure baseline, like your app is not installed on your device. So you have baseline level, and then you install your app, put it in the background, and you want to see that there is not much difference from your baseline. Because if your app doesn't work in background or not supposed to, you should not see this. And that could actually reveal some mistakes in your app development. For example, like someone could forget to release a wake lock, and your app is actually draining your battery. Or maybe your app is doing synchronization very often, and you keep waking up device and drain your battery. And those are very long-running tests that would show you what's going on when your app is in background. Yes?
Yeah, these things are all things we love to test, and like exactly how you do it is the trick there. Like, for the latency one, do you have to do it 10 times?
Yes, for every test, you probably want to do 10 times. Because there is a lot of noise, and you basically like, do the mean value of those. Yeah.
Do you report the results out of each of the tests and aggregate them into something else which decides if you exceed the threshold? How you do all this stuff? Which would be great if you guys could open source some of it.
Yes, so I think you answered your own question. Yes, we do report all the test results, and we have a service that aggregates them and would give you different percentiles. So like, for example, like here's your mean value, here's like your 90th percentile. So like you would, for all the like performance measurements, like latency, you want to get different percentiles. Because like it is very noisy. All the like performance tests are very noisy. Probably binary size is the only one that is not as noisy, because you expect to see the same results for every run. But like startup latency, like those numbers could vary a bit. So you do measurement on exactly the same device. So like the trick here is to make sure that you execute your task multiple times. Your device always in the same state. So like all the like background services, all the background apps are disabled. So like nothing will introduce more noise, and that you always start with the same like fresh boot. So like in our lab, again, that's the power and disadvantage of Google, right? So like we already have a team that maintain the like performance lab for us. So like what they do is actually do a lot of things that you're asking. They making sure that all the devices in prepared for performance. They would guarantee that you would run the same tests. Actually, you can request that on the same device. So you compare apples to apples. You have multiple measurement, and they actually like even like reboot device before they start a test. So like they reboot device, so like it would start fresh from the same state for you. And you do multiple measurements, aggregate them, get some statistics, and if you do it right, it would be less noisy. Yes?
Do you think any of this stuff would be published in Jetpack or Nitrogen?
I think, I hope so. Yes?
Are you using any special Android builds? Because if you are on Google, you're vulnerable to Android. And in that case, hopefully you can tune something.
No, we as Firebase, we don't use any special builds. We do test on beta. Like let's say when at Google I/O they announced a new beta version. So like we tested our Firebase SDKs that they work on that API level, that there are no conflicts. Maybe before they announced it, yes. But other than that, I don't think we do anything special. It's normal Android. We test on exactly the same. Yes?
You said before you were using Latency because of the speed of execution. Can you elaborate on that?
Can you repeat your first part of the question, please? Roboelectric, yes.
Unit tests. And you said you were using it because of the speed of execution.
Yes. So you can choose whatever framework is suitable for you, but we in Firebase specifically favoring Roboelectric more because it's running in JVM and it's much faster. Because you don't need to spin up Emulator. Because like we have our internal CI system, and if you use instrumentation tests like unit tests, you would need to run them on Emulator, and you would be hit with this constant time to bring up Emulator and run inside Emulator, which is slower than pure JVM. UI, no, we don't test UI with JUnit. We test only like pieces of code with JUnit, right? So like your methods or your classes, you can test with unit tests. Roboelectric? Roboelectric is a way, yeah, so basically it's a way to, it's a framework that allowing you to replace Android system, basically. Like you don't need actual Android to run your tasks. It has all the Android system classes mocked.
Question: is there any plans to enable mobile manual testing on Firebase? So right now it's just automated testing.
Yes, so we do actually do manual testing as well, like for our SDKs. I'm assuming that you're asking for
your customers.
for our customers. There are no plans that I'm aware of.
Thank you.
Cool, thank you.